For centuries, people have looked at the night sky and thought we were alone in the world. With each technological advance, we get closer to finding answers. And, in an announcement that could change our place in the universe forever, NASA has discovered the first signs of extraterrestrial space from Proxima B, the closest point to Earth. Proxima B is more than 4 light-years from the habitable zone of its host star, Proxima Centauri. This very simple and well-structured symbol created a wave of excitement and curiosity around the world. Could this be the moment when man realizes that he is not alone in the world? The path to this important discovery began with the careful observation of NASA's powerful telescopes, which looked at distant stars and planets for signs of life. Proxima B is still one of the main candidates in the search for extraterrestrial intelligence because of its shape and proximity to the solar system. The signal found was different and unlike anything astronomers had ever seen. It was a turning point in human history. The implications of this discovery are profound. First, it confirms the long-standing scientific hypothesis that other planets are habitable under Earth-like conditions. Second, and perhaps interestingly, it raises the question of what kind of people live there. Is it just a microcosm or an advanced being who can talk and walk? This signal from Proxima B is not just random noise, it is a universal phenomenon. It is a structural repetition that shows a conscious origin. NASA scientists and international teams are currently working to decipher this story and try to understand his story and intentions. The international scientific community is immersed in theories and speculations about the meaning of this message. Is it an invitation, a compliment, a warning, or something unexpected? The discovery sparked conversations on social media, in coffee shops and around the dinner table. People look at the stars in wonder and wonder what creatures exist on a distant planet. How is their world similar or different from ours? What does your community think about technology and culture? The world is wide. In addition, this analysis raises several ethical questions and concerns. How would people feel if that was a sign of intelligence trying to communicate? What protocols should be developed for interstellar mediation? More importantly, how does a discovery like this change our understanding of religion, our lives, and our identity as people? When the pressure is on, caution is also evident. Scientists at NASA and other space agencies are working hard to confirm these findings and ensure that the positive signal is not false or misleading. We are about to witness the greatest event in human history, so we must take the next steps carefully. The world is waiting for further analysis. Seeing alien signals from Proxima B not only brings our science into a new era, but also unites us with curiosity and hope. Perhaps we are very close to answering one of the oldest and most profound questions: are we alone in the world? In April 2019, a radio signal was detected from space, specifically from the Proxima Centauri region, 4.37 light-years away. Despite its distant appearance, it is the closest star to the Sun, 3 times the distance of the third brightest star in our sky. This symbol originates from a triple star system consisting of the binary pair Alpha Centauri A and B and Alpha Centauri C, also known as Proxima Centauri. Alpha Centauri A and B, 2 companion stars, are very close to each other and about the same size as the Sun. Alpha Centauri A is bright yellow and 1.5 times brighter than the Sun, while Alpha Centauri B is half as bright and orange. Alpha Centauri A is smaller than our Sun and Alpha Centauri B is smaller, so our Sun is right between them. But where is the point between these 2 stars? The designation is Breakthrough Listen Candidate 1, BLC-1. The project, with a budget of nearly $100 million, includes thousands of hours of observation with advanced telescopes around the world. The signal was detected by the Parkes Radio Telescope in New South Wales, Australia. This telescope observed the region of Proxima Centauri, the nearest star to our Sun. The proof was not found in the books of data collected in thousands of hours, but the researchers found a needle in the haystack. For a symbol to be valid, 2 different conditions must be met. First, it must be limited to a low-frequency range, since these radio signals are not generated by natural machines in space. Second, the frequency must change based on the exoplanet's relative motion to Earth. About 4 million points were recorded by the telescope in Australia by the researchers. After extensive analysis and removal of unwanted signals, 5,000 unique signals were found, one of which could not be decoded when scanning with modern radio transmitters. On the ground, this unique signal, with its narrow optical signature, only appears when the telescope is aimed at Proxima Centauri and can be seen within 30 hours. After analysis, it was determined that the planet came from Proxima B, a planet discovered by astronomers in 2016 using the radial velocity method. This technique detects changes in a star's position due to the pull of rotating planets. This star shows a small circle, and scientists use sensitive telescopes to track the starlight. As he moved away, the light spectrum turned slightly blue. These movements occur in daily patterns throughout the day, month, or year, and the lunar cycle is attributed to the rotating planet's circulation. A closer look reveals that Proxima B is very close to Earth, 1.1 times the diameter of Earth, and 1.3 times the mass of Earth. However, there are significant differences. The first is the position of the two planets in their respective solar systems. Proxima B is only 5 cents closer to its host star, while Mercury is 39 cents from the Sun. This proximity makes Proxima B the hottest planet, but because Proxima Centauri is a faint red dwarf, it receives 60% of the Earth's energy from the Sun, placing it where necessary to support life. There are many unknown planets scattered around our universe. So far, we have discovered 4,935 exoplanets and 65 new planets, bringing the total to 5,000. This new group of 65 exoplanets was added to NASA's Exoplanet Archive on March 21 of this year. A revolution in planetary exploration. The James Webb Space Telescope, JWST, is the most advanced telescope ever built and is 100 times more powerful than its predecessor. With his help we can unlock the secrets of the universe. In the past, we have discovered a wide range of planets, from small rocky worlds to gas planets larger than Jupiter, to the hottest and most habitable planets. In these observations, some of the planets stand out. Kepler 1649c is one of the planets with similar properties to Earth. In fact, it is the most beautiful planet we have ever seen that can support life. We've found 55 Earth-like planets so far, but we haven't been able to study them all. With our rapidly advancing technology, especially thanks to the James Webb Space Telescope, we know what else we can do in the future. Wouldn't it be wonderful to discover a planet that could support life? One of the main goals of the James Webb Space Telescope in its first year of scientific operation was to find and study exoplanets outside the solar system, focusing on how they formed. And it is created in water and organic matter. The extensive internet research into star and planet formation allows us to link studies of mature exoplanets to the conditions of their birth, and also to link our own solar system to their origins. Webb's infrared capabilities are ideal for revealing how stars and planets form for three peculiar reasons. Infrared light penetrates dust well, detects the thermal signatures of young stars and planets, and indicates the presence of key chemical components such as water and organic compounds. Mid-infrared light can pass through clouds that are 20 times denser than visible light, which is especially important when observing newborn stars hidden within their natal clouds. These infrared capabilities are crucial because they allow us to observe and capture the early stages of star formation when gas and dust are still contracting to give birth to young stars, but there is much more to the natal clouds of stars than that. Both young stars and giant planets begin as huge, swollen structures that gradually contract over time. As the new stars heat up over the years, the giant planets cool, but both are brighter in the infrared spectrum than in visible wavelengths. Webb's prediction will help find new stars and planets and understand the physics of their formation.